Alright, we're going to be solving some basic equations with logarithms, and one of the things you want to look for is the same base on both sides. So if these logarithms both have the same base, these are both log base 5, all I'm going to do is cancel these out. They have the same base, they cancel out, and whatever's left over, I bring that down, and it becomes an algebra 1 equation where I'm just solving for the variable. Okay, so if the logarithms have the same base on each side of the equation, they cancel out, and I'll just solve for the remaining variable. So here I have 2n plus 10 equals n plus 7. I would get the variable to one side first, and then I would solve for n. So here I would get rid of this plus 10 by subtracting it, and my answer would then be n equals -3. So if you ever see a logarithm where the log base is the same on both sides, those bases are just going to cancel out, and you bring down whatever's left over. Whatever was with those logarithms comes down, and you would just solve the equation for x, just like we did in Algebra 1 where you were just solving for a variable. Now sometimes your logarithms aren't going to have a base on each side that's the same. If you see something like this where we don't have the same log base on both sides and I can't just cancel something out, what I'm going to do is I'm first going to isolate the logarithm. So I have this log base 2 to the x. I'm going to isolate that first, get rid of whatever else is over here, and I've got this -6. So to isolate this, I have to get rid of the -6, add 6 to both sides. Now I have isolated this logarithm. Now it's just log base 2 to the x. I've gotten rid of the -6 by adding it to both sides of this equation. Once you have isolated the logarithm, you've gotten this log by itself over here. I'm just going to write this in exponential form and solve for x. So I'm going to rewrite this logarithm. This is log base 2 to the x equals 4. Well, remember when we were rewriting these in exponential form, whatever the log base is, that becomes the base to my exponent. And then I'm just going to switch these two over here. The 4 and the x, they're just going to switch. So this becomes 2 to the 4th power equals x. Okay, now to solve this, I'm just going to figure out what is 2 to the 4th power. 2 to the 4th power has to give me something, and whatever that is going to be my answer. And 2 to the 4th power just happens to give me 16. So my answer would be 16 equals x. Now, one more quick example here. Now, I have a log base 6 to the x plus 4. I don't have a log on both sides with the same base. What I always want to do is I want to isolate this logarithm. Over here I've got log base 6 to the x plus 4. I want to isolate this logarithm. I have to get rid of the plus 4. So what I'm going to do is subtract 4 from both sides. And that gives me log base 6 to the x equals 5 minus 4 is 1. So here is my new logarithm, and I have to rewrite this in exponential form before I can solve the equation. So this log base 6 is the base to my logarithm. It's going to become the base to the exponent, and I'm going to switch these two around, and that becomes 6 to the 1st power equals x. Okay, so I'm just figuring out what is 6 to the 1st power. Well, any number to the 1st power is going to give me that number, so that would be my final answer. So before I start trying to solve these equations, make sure whatever I do is I want to isolate the logarithm. I want to get whatever that log base 6 to whatever power is. I want to get that by itself before I can solve the equation. Now sometimes you'll see there will be something in front of the logarithm. The easy way to get rid of this, now I have an 8 in the front, and there's two different ways I can do that. All right, this is 8 times log 6. To get rid of multiply, I can always divide by 8 on both sides first. And that would essentially isolate this logarithm. Now it's just log base 6 to the a equals 16 divided by 8 is just 2. All right, so now I can solve this. I can rewrite this as exponential form, and I can solve for a. Okay, so I to get rid of this 8 that was in the front, this technically just like a variable like 8x, to get rid of that 8 in front of the logarithm, to isolate it, we always have to isolate that logarithm, I had to divide by 8 on both sides. Now this is isolated, and I can write this as exponential form. This 6 is going to become the base to my logarithm, and we're always going to switch these two. So 6 squared equals a. So 6 to the second power equals a. So my answer is going to be basically figuring out what is 6 to the second power. So a, 6 squared, I know that is equal to 36. So my answer would just be 36 equals a.